Hello.
Hey,
How's it going?
it's going good, man. How are you?
Pretty good.
Uh, can you just give me a brief background of you, even just before getting started?
Sure. So I'm a CS student at the University of Toronto, and I'm just doing some practice mock interviews on the platform to prepare for new grad roles.
Okay, so are you a master's student or an undergrad?
Undergrad.
Okay, okay, cool. So how comfortable are you with the data structures and stuff?
I mean, adequately.
Okay, good. Uh, okay, let's get started. So what I'll do is can you go ahead and choose the language of your choice?
Sure. I'll be using a Python for this.
Okay, you're comfortable with. Okay, and let me type the question here. I'll give you some in test cases as well, and I would want you to when you're running your after writing your code, I want you to run through the test cases as well.
Sure. Sorry. So are you putting out test cases, or okay, you're adding some as well. Got it. So going through, the output is 3, and 3 is 0, 1, 2, 3. That's where the sums end up matching.
Right.
Cool.
Okay. I gave you two test cases. So yeah.
Gotcha. Okay, so going right through, immediately what I imagine would be useful is to actually, let's say in a naive case, end up storing, say, some sums that go from the left as well as the right, right? So let's say we had a left array that is n length long, where n is the length of the input array, and a right array, which is, the same thing, except it's summed from the right.
Okay.
What you could do in that case is go through and compute these values, by just iterating through to the indices one by one. And then what you would want to try and find is some index where the left at the index is equal to the right at the index. If there is no such number, then you would output -1. Otherwise, you would return that index, right? So
Right.
the complexity for this ends up taking big O of runtime and big O of n space, where n is the length of the input array. So that is a solution. Let's see if we could actually do this without additional space, or at least not linear space. So the thing that I'm doing itself is I'm starting off with the thing that I'm really storing is the sums, right? But I don't care about all the sums. It seems like once I have a sum, I may want to discard it, right? So what happens if we use two separate pointers and start from the left and the right? As we go along, okay, see the problem with using a left and a right pointer, if I advance both of them in tandem, is that I may end up having, say, I'd only get the middle position, right? But
Right.
my pivot may be left of that middle position or right of that middle position. So
Okay.
I should actually get a clarifying constraint. So are all these numbers going to be positive?
Yes, you can assume
Okay,
that.
got it. So if all the numbers are positive, that actually gives us a condition on which we could advance our pointers. So what we should have is both the pointers start off at the left and the right, and they're going to be set to their initial values, right?
Right.
And what we say is if the values are, if the pointers are the same, and their values are equal, then we have a solution. If the pointers ever advance past each other, then we don't have a solution. And at each step, we either advance the left pointer or the right pointer, depending on the sum that we've calculated so far. Whichever sum is lower, we should be advancing that pointer. So as an example, when I have 1, 7, 3, and 6, I'll start off with having left is equal to 1, right is equal to 6. I see that left is less than right, so then now the left pointer gets updated. So now that left is 8, right is 6, and then we end up with 11. And afterwards, we end up adding 11, and we see that both the right pointer and the left pointer are at the same index, and they have the same value. Therefore, the pointer is, 3.
Yes. Yes.
Cool.
That's good.
So given that, the big O of n runtime and big O of 1 space complexity solution, I think that's pretty much our minimum bound. Is it okay if I code that out?
Yeah.
Sure. So def pivot on the array. What we're going to say is left pointer and right pointer is equal to 0 and len of the array minus 1. And then left sum, right sum is going to equal to array of left pointer and array of right pointer. So there's just a boundary check on this, which is that if the array is none, or I guess a valid input is that there's only one item, right? That's also something I didn't ask about. What if the array is just say 1? Do I return 0 as the answer, or do I return -1?
You can return 0.
0? Okay. Got it. Cool. So in that case, we don't actually have to handle any special case for, the one item array. So basically we had while left is less than or equal to right. What we want to do is go through and update the pointers based on what we found, right? So we see that if left is equal to right, you know what, I can just update this to left and right so that I have to type a bit less. If the values are equal, then what I should be able to do is say if the left sum is equal to the right sum, then I just return, one of the pointers, right? Otherwise, I would break. Or I would advance one of the pointers so that, this condition is no longer true. Otherwise, I say if left sum is less than right sum, I'm going to move up the left pointer, and then left sum plus equals array of left. Otherwise, I move back the right pointer, and then right sum minus equals array of right. Cool. So that should be the translation of the idea that I had above. Let's just try it on the simple test case, because there may be a bug here in how I'm summing. So let's go ahead and check what this array. We start off, we check, the array isn't none, the length isn't 0, cool. So left is set to 0, and then right is set to the last index. Our left sum is currently 1, our right sum is currently 6, just like last time, just like when we were, trying to form the idea. So cool, left is less than right, the values aren't equal, the left sum is less than right sum, so now left moves up to 2, and the sum moves to 8. Next loop, we see now that the values aren't equal. Left isn't less than right sum, so now we move right forward by 1. We're going to have 11. So the main reason for checking the test case is to just see that this terminates, because I wasn't entirely sure about that part. Though it seems like the pointer advancing part, there's no way we got that wrong, right? But next loop, we end up hitting the value of 3, right? So now at this point, we see that still our value is lower. We have 11 added. And now here's a bug. Our left and right aren't equal, but at the same time, we don't have, we don't have left sum is less than right sum. We're going to hit else. And now the right pointer is actually going to get updated to 17, which is incorrect. So this doesn't terminate correctly. It's okay for most of the pointer advancement, but the actual condition for checking, when we should break is a bit off. So instead, what would it always be? When we say that the left and right side are equal to each other, really that means that we aren't including that middle value, right? But is that true? because all we care about is the index. We don't care about the sum, right? Because if both of the pointers are on the same position, then it doesn't really matter what their values are. If they're if they're equal to each other by the time they get to that position, that means that both their left and right side are equal. So let's continue and say now we do have 17, right? And so now right is at index position 3, and left is currently at index position 2. So we'll advance. In the next loop, we see that left sum is less than right sum. We move left up. This gets moved to 17. And now both left and right are at the same position. So we'll see that left is equal to right. The sums are equal, so we return that position. We did get the correct answer. It's just, it seems a bit different just because we're actually comparing the values. We're seeing that if from the left and the right, the value at that position is the same, but that's the same thing as saying that the values on the left and right are the same. So the normal condition, the normal test cases seem to work out fine. Reasoning through for what would happen in the other case, it seems like all you would end up with is that left is equal to, 3, and then right is going to end up equaling 5, and then you'll fail the case, so you're going to break and return -1.
Return negative.
Yeah. And for the empty array, I think we can also reason that we would end up with the same thing, that immediately we'd see that left is equal to right, the sums are equal, we'd return and get 0. So given that, I think that will be my solution.
Okay, that's pretty fast. Let's move on to the next problem.
Sure.
And take your time to read through the problem, and then maybe I'll go down and then face the problem here. Okay, and just read through it. I'll try to give you the.
So I've actually done this problem before. I guess I could describe it, and we'll go with that. So
okay. Can you do that?
Sorry?
Can you describe the problem? No,
yeah. So basically, what you end up having is that your option is to pretty much, whenever you push an item, you would push, the value onto the stack, as well as push on what the minimum value at that point is. And so
I think you just.
Oh, sorry, the max. The max. I mean, it's the same thing, right? It's just the max instead of the min. Oh, okay. Sorry, I read through it again. I thought I was supposed to just get the max in constant time. I haven't done the popMax before.
Yeah, that's the beauty of the problem. It looks.
Got it.
But it's at the same time it's not that easy.
Yeah. Okay. Sure. So in that case, we could go through this one. So I can start off with just describing how this would be structured without the popMax, and then we can continue from there. So
okay.
If I only needed to peekMax, the main thing I could have is, let's say I have my stack. Whenever I append, I can have 2 separate stacks. So one stack is just gonna, keep my items that I have.
Okay.
And the other stack is pretty much gonna keep track of, let's say, what my max is at some point, and for how many items that is my max. So I would have, say, 3, which shows up one time, and then I would end up with a state of 5, 3, because for at least 5 items, or for at least 3 items, 5 is the max. So when I pop off that 4, my count of when 5 is the max is now 2. When I pop off another time, the count comes to 1. When I pop off, the final 5, it goes to 0, and I pop this entire thing, and suddenly my max is 3 again. Does that kind of make sense?
Okay.
Like I'm keeping one stack for just the items, and I'm keeping a separate stack to, keep track of what the current max is. and for how many items is the current max.
Mm-hmm.
Sure. So if I need to retrieve the maximum element in the stack, what is, say, the desired complexity for that? I'm guessing that's definitely not constant, right?
Okay, so what do you think the complexity is going to be with your solution?
So for this, the complexity would be n, right? Because if I were to try and pop the max, I'm thinking that I would have to keep on, popping off all elements until I find a max value, then decrement that count, then put those values back on.
Yes. Okay. So that can you do it in any better time? You can definitely. I mean, there is a definitely you can do that, but can you think of
Okay,
it?
so of a better way to do that.
Yes.
Yeah. So one thing uh, So what you would normally be able to do, let's say, is if you wanted to avoid, you know, removing an item, then shifting over all of the existing items in an array, one option normally would be to keep, just swap the last value, but that messes up the order of our array, so we can't do that. Alternatively, if you were to store the entire stack in the format of a linked list, you should be able to remove some arbitrary item from the linked list if you had a pointer to it, and that would work out for getting rid of items from a stack. Let's say it's a doubly linked list.
Yes. Yes.
That would give you the constant time that you wanted.
Right. Perfect. So why don't we start coding up on that then? Now that we have
Sure.
an idea of like what to do and what data structures to use, so why don't we just go ahead?
Okay, let me think about actually if you necessarily need to use a linked list, right? Because the code in that case gets pretty complicated for certain edge cases.
No,
Is there another structure?
just take a try. Let's work on the problem together, and then yeah, get to the solution.
Okay, sure.
Yeah.
I was just thinking of some of the structures that you get in Python. But we'll go ahead with this. Self, comma, data, previous, none, next. Sorry, I can't use next. Right, so this ends up just being my linked list structure, or a single node structure, and then the function, the thing I want to actually create is a max stack, which is gonna have all the operations we talked about. So that's def push self item, then pop the top peekMax. Cool. So right, normally I would want to say have a self stack is equal to an array, but in this case I can't necessarily do that, right?
Right.
Instead, I would want to have, let's say, the head and the tail of the structure.
Good. Good. Go ahead.
I'm actually thinking of something that would be useful. Is that just for say coding simplicity on the stack? Oh, never mind. I was gonna say maybe if I have a dummy value at the beginning, I could swap, but no, there's really no way to avoid having to reallocate a bunch of items unless you use linked list. So,
do you think just using the linked list would help solve the problem?
Just using the linked list would help solve the problem?
Yeah.
You mean the problem of not of for popMax?
Yeah, popMax, but can you do it in order of log n? popMax.
Order of log n. Uh, so it seems to me like if I had a
So,
linked list with a
okay,
hash table, there should be no problem, right?
okay, okay.
But you're saying you don't want to go with this approach and instead find a log n approach?
No, no, no. The problem with hash table also, then how do you maintain this the maximum value? Okay. So
So you still have,
if you
right?
have, I mean, say suppose you are using a hash table, okay, and you have to perform a pop max, okay,
Yep.
then you exactly don't know in which position is the max element there, right? Okay. You can do it in order of one on the linked list, okay,
Right.
but
Okay. I see what you mean.
yeah, how do you
Yeah.
identify the value in the hash table?
You're right. It's because you yeah, okay. It's because if you have that separate list that we talked about earlier that, has these counts,
Hmm.
you can't really update that, right?
Right.
I mean, I guess yeah, you won't know what the other max values are now that you've removed that value.
Uh-huh.
Uh yeah, you're right. Um so this wouldn't work out. You're saying there's a separate way that you could do this in log time.
So
Uh
think over it. I'll and if you're not able to do, maybe then I can help you.
Sure. So, uh, right off the bat, when I think of finding the
Just think of
max between some elements, I think of a heap.
yeah. Just think of the
Um,
data that provide you the login functionality. I mean login complexity for identifying a particular element, right?
yeah. So, the like a heap should give me the login complexity that I want for popMax, because all you have is that you have the invariant, which is that the root is going to be greater than all the values in its subtrees. And as soon as you decide to pop the max, you remove the root, and then you need to, put in a new root and rebalance, right?
Mm-hmm.
So that rebalance step takes log n time to complete.
Okay.
But how does that fit in with everything else that we have? So let's
So
say we had,
so that's not a good choice then.
what do you mean?
Using heap is not a good choice then, right?
Because it doesn't fit in with the other data?
Yeah, with the other data structure.
Right. Okay, I was going to see if there was a way I could combine the heap with something else, but you're suggesting to not go with that either. Gotcha.
Have you
Uh,
ever used a tree map?
sorry?
Have you ever used a tree map?
That's just like a hash table that is
Oh,
stored as a tree. Sorry, it's just a map that's kept in a tree form, like as a red black tree, right?
right, right. So what is the advantage that we are gonna get instead of using a hash table over a tree map?
Uh, I guess it's sorted in order, right? So
Yes.
when you need to peak max, the max value should end up being the rightmost node on the tree.
Uh-huh. And how about the pop max?
Similarly, it's going to take log n time because you're going to have to rebalance the tree after you remove the item.
Yeah, you can think that way, or you can think that while building the tree itself, it would take me a log n to do that, right?
Right.
Okay. So, so do you think that using tree map would solve our problem?
Uh, so how would it work out for the actual items in a stack though? Because we still need to maintain the normal order, right? Of push, pop, top.
Yeah.
So this still has to be combined with the existing structure.
So,
So if you're still using an array, uh, as the stack structure, you can't do that, right? Because that'll still take n time.
Yeah. So you mean to say TreeMap cannot provide the stack functionality, right?
It can't, yeah.
Okay. So why don't we combine both linked list and TreeMap?
Okay, so in that case, you end up so for that, I don't think I could actually write out the code in Python just because it doesn't have an actual TreeMap
No,
implementation.
I don't want the TreeMap implementation for you to be do. Just assume that there is some class, okay, of TreeMap, and that gives
Right.
you. I just want you to go through the logic for each of the operations that you have to do here.
Okay. So in that case, what would we have? So I'm not following on the difference between using the TreeMap and the heap.
Just
Because
think,
it seems like for both of them, we're only using that data structure to keep track of what the max is, right? So what is the trade-off that you make between choosing those?
so okay. If you were to use a heap, how do you build your node in the heap
Oh,
node?
how would you remove the top? Got it. Okay, that makes a lot more sense.
Yeah.
Yeah, if you had like I see. Gotcha. How does the tree? So I guess also clarifying constraint in the stack. Does it support duplicate items?
Yeah, it might.
So how does a tree map actually work for when you have duplicate items and you decide to do a lookup? Does it just arbitrarily pick one of those nodes?
Yes.
Got it. Okay, cool. So I actually do see where the tree map would be useful because now when you have to remove an item from that tree map, you can just do the lookup, right?
Yes.
So
And the
sure.
topmost element you can get it in order of one because you know the maximum element you can get it in order of one because it's already sorted on the keys, right?
Uh, I mean, it's not order of one, right? You have to traverse through from the root to the rightmost node, right?
Yeah, I mean like assume if it is already built. Yeah, I get you. It's order of log
Yeah,
n, right?
yeah,
Okay, because
yeah,
it's
because that's like the maximum height.
you
Uh,
yeah.
right. Okay. So combining the ideas of the tree map and or let's just say the red-black tree and the linked lists, what do we really want to happen? So we still want to um, build up items using a doubly linked list in order. So push and pop are going to just add to the linked list,
Yeah.
but there's also the extra step where we're actually going to delete whatever value we had for the node inside of the tree map. For
Right.
getting the top value, it's still getting the tail of the linked list. For peekMax, you would want to just find the rightmost node and return that. For popMax, you want to find the rightmost node and then you want to run the delete operation on the tree map. That should be the entire set of things we have to do in order to maintain this max stack.
Yeah.
Is it okay if I code that out?
Yep. Yep. You can
Cool.
add a dummy class for TreeMap and write
Sure.
whatever option that you want to present there. Okay. And let's see if you can type in. Yeah.
Right. So I'll just leave that empty for now and assume that there is, some functions for deleting and looking up values. So yeah, actually I can, yeah, I'll come back to that just because the push part won't have that much involvement. So do I actually need a doubly linked list? Yes, I do, because if I remove something from the middle, both of the sides need to know about each other. So
Yeah. Do one thing. Okay. For each of the operation, okay, just write down in words whatever you can do, and then maybe then we can write it up in code. Yeah. However
yeah,
you
so
feel.
sure. I talked a bit about what each of them were doing. I was actually thinking if using this other structure that Python has called an ordered dict would be more useful, but it turns out no, because I don't think that can handle duplicates. This would have simplified the code a whole bunch because I could avoid not using, pointers,
Okay.
or I could avoid using linked node, but that fails for duplicates. I was just thinking about that.
Let's modify the problem. Assume that we don't have any duplicates, and then use an ordered dictionary, and then let's solve the problem first.
Sure. I mean, okay.
No, my whole point is to see how well you can use the data structures. Okay, the combination of both of them in solving.
Yeah. I think I'll go ahead with the the pointer thing, just because the more I think about it, the ordered dict is more relevant if I wanted something like an LRU cache, not necessarily this. Yeah. So let's say that when we push on, what we basically want to do is append to the tail. So set that self.tail.next is going to end up equaling a linked node with the data set as item, the previous set as self.tail, and the next set as none. And then we'll set self.tail is equal to, this new node. And we'll also want to update, right, the actual link structure.
There is no next. There is a follow.
Yeah. Or just because I can't, next is a keyword, so that's the main reason I'm not using it.
Yeah.
Cool. So just reasoning through that, all I'm saying is that as I'm appending, I'm going to go ahead and append to the end of my linked list. I have a dummy node in the beginning, so I don't really have to modify self.head because that's just a completely invalid node. And cool, so that part's done, and all I should have to do is I have in my init structure, I should also have a self.tree is going to end up equaling a TreeMap that we're going to initialize with, say, as empty, right?
Yeah.
And then what I would want to do is self.TreeMap or self.tree. Say one of the operations I have is to what? Okay, sure. Based on the value, some node, right?
Yes.
Because yeah, that's the main thing that I'm looking up in here.
Hey,
cool.
So how are you trying to? Okay, the head is a dummy node. Okay, the tail is also pointing to a dummy node. Okay, and okay, fine.
Sure. So now when I want to get pop, this is the place where I have to care a bit about head and possibly raise an exception. If it turns out that the tail is, if tail is head, then I have an exception because now I'm trying to pop off of an empty stack. Is self.head, then I raise exception.
Exception, whatever. Yeah.
I forget what it's called. Value error. This isn't the actual thing, I think. Say can't pop from an empty list or empty stack, and that's that. Otherwise, what I want to do when I pop is get the node as being the last item, and obviously I would want to return the node.value or node.data. And in the middle, all I'm going to say is that self.tail is going to end up equaling the self.tail.previous or prev, and then set self.tail.next is equal to, I keep saying next, but I called it follow, set to none. So now we've removed the final node, but we also have to go through and update the TreeMap values. So I'm not entirely sure how it works out. So what I'm thinking is I should be able to do something like this. That, right? But how does this work out for duplicates? Like, how do you actually, does it just maintain internally that you're only moving one of the values?
Yeah.
Right. So my question was for the operation I'm doing on line 116. Does the TreeMap handle duplicates so that I can just do this right off the bat?
Yeah, I think I need to check on that.
Because I assume that normally if it operates by key lookups, right, it's only allowing one associated value. But it seems like in this case, I can
Yeah,
associate multiple values with a single key.
yeah, I don't think TreeMap does. Yeah, because it's all about looking up on a key, right? Like if the
Yeah,
key is duplicate, I don't think it can allow a duplicate key. Yeah, you're right.
I see. So in that case, I would probably need to do separate logic, which is gonna say inside of my tree map nodes, uh, or say inside of my link node, I need to have a count or something like that, right? And I would have to update my tree map value so that it has a count.
Yes.
I guess for code,
Yeah, you
simpler
can.
code, can I assume that it's unique values for here?
Yeah, you can use a combination of an item and then
The
yeah,
count?
or for now, I just assume that there are no duplicates, man. Just make our lives
Sure,
easy. Yeah.
sure. So top, I have the same exception. Um, can't get top from an empty stack. And basically what I want to do is return self.tail.data. And peekMax,
Mm-hmm.
let's say that I have, I guess it's kind of cheating if I say just get max on my tree, right?
It allows that particular
Let's
operation.
say, okay,
It allows
so I guess in that case, I want to return self.tree.getMax,
Mm-hmm.
and popMax is going to be the highest self.tree.max, and then I want to return highest, but in the middle, I want to remove that value. Self.tree.remove highest. Um, so slight error, and that highest should return a node, and I want to actually operate on the data. Cool. So let's say that I have these operations again. It was that I should have put self value def get max, and I had def remove self key.
Mm-hmm.
So that's my API for the tree map, right?
Yes. Yes.
Cool. So
Okay.
given that, I think that ends up being my code.
Yeah. So this is the code for handling without duplicates, right? Okay.
Yeah.
So how can you improve the code to handle duplicates?
Yeah. So what I'm thinking right off the bat is because I'm actually storing, say, this count inside of, or because I'm actually storing the link nodes as the values inside the key map, what may be useful is if I set a value called count inside of each of the link nodes,
Count is
just
the
so
idea
that,
because
sorry?
okay. How does adding count variable will make our life easier?
So what I'm thinking is that when I do the remove operation, a tree map, if it's a custom class, we should be able to update it so that when you decide to remove, you don't remove the node if the count is greater than 1. If the count is greater than 1, then you just decrement the value of the count.
But you need to actually
Um,
delete it, right?
you won't need to delete it unless the count hits 0 when you decrement.
Mm-hmm. Okay.
So that's an option. An alternative option is that I don't know what kind of operation, what kind of modifications you're allowed to make to the tree map, but maybe if the data that you were allowed to put in, I guess this doesn't have to be in the link node structure itself. It could be that we put node and then the count here, right?
Okay.
You get what I mean?
Rather, what I would suggest is like, why don't the tree map save key and a list of all the nodes associated with that? Okay. So then you would be removing the exact node that is on the top of it.
I see.
You get my point, right?
Yeah, I see the point that you're having, because if you just use a count, you don't know what node it's referring to, right?
Yeah, that's the point. I mean, you exactly don't know what node you're removing.
Yeah, you don't know, because you need to get the node itself. Yeah, when you decide to popMax. So there actually was an error over here with my popMax operation. I'm supposed to also, from the highest node, set that highest dot.
Get the list of the highest.
Follow, and then, so I'm on line 142. This is some code that I didn't change. I'm supposed to also do something like that, but there's edge cases involved for the case where the highest actually turns out to be the tail, which I did not account for. Yeah, so if the highest is the tail, this is a bit different. Tail. Then in that case, what I would want to do is just set self.tail is equal to highest.prev, and then self.tail is equal to none. Else I do this. Yeah, so I see the point that you're making about storing the linked list instead of just the node.
So where are you putting a list there?
Oh, so I wasn't sure if you wanted me to code that out.
Yeah, I want you to code that out.
Got it. Okay, sure. So let's see how I'd actually end up updating this. So instead of
so what's
having
to push? So if there is.
Yeah, so instead, let's say that I just have, I can't modify the tree map, then what I would have to do is check first if the key exists, right? So let's say there's also the def get self on a key as part of my tree map operations. So so the node is equal to self dot tree dot get for some key. We say that if node is none, in that case, we should be able to just put that, item in. And otherwise, let's see, what order would you want the linked list to be in, right? You want to have it so that the newest node is always the head. So
No. I think you're not getting my point. Just hold on here. So what you're trying to push, right? You're creating a node. Okay, you're appending it to the tail. Okay, and just updating the tail. Okay, and what you're doing is there is an item associated in the map already. Okay, you are fetching that map, and if that map is not none, okay, then you're trying to put. If it is none, then you're trying to put it the node. Else, what are you trying to do else?
Otherwise, what you'd want to, I imagine, do, given that you only have the the tree map operations.
No, here what I would want is if node is none, okay, then I would want to do is node is an array and node, okay, then just you got that.
I see. Got it.
No, this should be node underscore list and node underscore list. If either ways is like you can just append it, right? Like if you get either an empty thing. Or
yeah, so I assume that you wanted a linked list as the value inside of your tree map, but yeah, I guess it's a lot simpler if you just use an array.
No, I think you're not getting my point. Like there are two data structures that we are using here. One is a doubly linked list, okay, which keeps or which mimics your stack, okay. One another data structure is TreeMap, okay, that mimics the order set of keys, okay, and values are list of nodes in the linked list, right?
Right.
Okay. So, and why are you so you are trying to use the linked list again in the values?
Yeah,
So,
and I see that that wouldn't work. Yeah, because you end up having, let's say that there's some node that points to some x and some y as previous as next, and then the following linked list should, let's say it has 4 and it points to z and b, right? And I can't modify these previous and next values, so I have to use an array. I'm following what you're saying with that.
so you got what I meant, right? Yeah.
Yeah.
Yeah. Now go ahead and try to fix the problem.
I was thinking that it would have a separate, what I was thinking is that I would have a separate list. So this is actually a separate list, which has the doubly linked list as data, and then it has, you know, next over here. But I guess that kind of overcomplicates things, right?
You're trying to complicate the problem, or
yeah, there's no need to do that. But yeah, this is what I was thinking of as what would be stored internally, where the data is the doubly linked list, and you have your next pointer pointing to the next item.
Not
but
yeah, and
but it still has the correctness property.
Yeah.
Right. So you're saying that we're going to get the node list.
If node list is empty, length of
yeah, if node list is none, then you have that, and then you append. Otherwise, you're going to just, you're going to node list append the node to the node list both times.
And you update.
And then you just have to put, right?
Yeah.
Yeah. So I guess really this code can be the same for both of them, and all we have to say is that the node list is equal to. I guess you can't do that because of lexical scope. So rip. You have to do it this way, both ways. Cool. I'm pretty sure that ends up being it for push, but for the other items, it's definitely a bit different.
The other items as well. Just keep on doing that.
I meant for the other methods like pop. Pop is now different.
Yes.
Because now instead you would get the node list based on the value. So all you would have is node list is equal to self.tree.get on node.data, and now you would let's say have your node list and you want to pop, right?
Yeah.
And if it turns out that new list is empty, only then you remove the value. Otherwise, you just do another put. So turns out if len of node list is equal to 0, then you would perform your remove operation. Otherwise, you would self.tree.put inside of node.data your new node list.
Perfect.
Yeah. Cool. We do end up needing to modify the popMax as well. So here we ended up popping the entire thing, but instead you would again want to do similar to normal pop, where you are going to get the node list, check for length of 0, otherwise append. So let me just copy and paste and modify the code I had. So again, we're just getting the node list. We pop if the new length is 0. Yeah, this seems to be okay for the if-else conditions on line 71 and 173. The only difference is that we return highest.data.
Right.
So cool.
So yeah, that's what I was looking for. So I think you got that.
Oh, what just happened?
Hello.
Oh yeah, sorry, you just disconnected for a while.
So that's what I was looking for. So how do you handle the duplicates part? Okay, and a good homework for you would be to build a tree map on your own. Okay, and then see how you are able to achieve the problem. Okay. Because Python does not support a tree map, right? Like it would be a good exercise for you to build your own tree map. Okay.
Right, but that's pretty much building your own self-balancing tree, right?
Yeah. Yeah.
Huh. Okay.
I mean, I don't want it to do it now, or maybe you can take it as an exercise later. Okay.
Yeah, because it's probably it's definitely outside of like, what you would do in an hour, right?
No, I mean, I didn't expect you to build a tree map. Okay. So yeah, but definitely have it handy. I mean, when you get time, try to work on that building tree map, and then maybe you can use it later sometime, right?
Right. Uh, cool. So,
Cool, man. That's
does
it.
that end up being the full
If
thing?
you have any questions from me, just let me know.
Sure. I guess like, are you uh, also interviewing for other places, or are you just kind of like doing this in your spare time?
No, I like problem solving, and I also help a lot of people with interviewing and stuff. So I just do it as a hobby. So
Gotcha.
yeah,
Gotcha. Okay. Yeah. I guess there's a mix. There's the group of people who are hiring for their companies, and there's people who are also, interviewing. So yeah, I was just curious.
yeah. I mean, like our company is also hiring, so I don't mind referring you there. But I don't know, like when will you be available for your full time position or interviewing with them? So
Okay, I guess sure. If you wanted to do intros afterwards, I could follow up with that, just so that it remains private for this recording they're doing.
yeah, that's fine. That should be fine.
Cool. Well,
Yeah, we can
awesome.
get in touch.
Thank you for.
We can share our details and maybe get in touch later. Okay.
Sure, sounds good. Thank you for your time.
Yeah. Thanks very much, man. It's a really nice talking to you.
Yep. Have a good day.